The stethoscope. The history of the stethoscope. In 1816, the stethoscope was invented by René Laennec in France. It was just a wooden tube, and you could only hear the sound if it was emanating from one position. He decided to invent one due to him feeling uncomfortable placing his ear on a woman's chest to hear the heartbeat. He noticed that a rolled piece of paper could amplify the sound without physical contact. Even though his invention was similar to the ear trumpet, historical hearing aid, he called it a stethoscope, which means chest scope. In 1840, Golding Bird was the first to publish about a flexible tube stethoscope that had one earpiece. In 1851, Arthur Leard invented a binaural stethoscope, and in 1852, George Philip Cammon perfected the design. In the 1940s, Rappaport and Sprague designed a new stethoscope, which became the standard design. The new stethoscope had two sides. One was used for respiratory system, and the other side was for the cardiovascular system. The design was heavy and short with two large independent latex tubes, connecting to an F-shaped brass binaural ear tubes. In the 1960s, David Lippman created a lighter stethoscope, and it had improved acoustics. In the 1970s, 3M Lippman created a tunable diaphragm, and then in 1999, Richard Deslorius created the first external noise-reducing stethoscope. It had two parallel lumens that contained two steel coils, which dissipated other noise as inaudible heat energy. Here is a picture of the scanning electron microscope image of the tubing of the stethoscope made out of polyvinyl chloride. Beginning in the 19th century, the stethoscope has evolved through many materials, starting with cedar and pine wood stethoscopes in 1816. In the mid-19th century, we began to see a shift in the material from wood to aluminum and hard rubber stethoscopes. The first binaural stethoscope that is commonly known today is composed of many different materials, including ivory or ebony earpieces, with wires layered in rubber that is coated in either silk or cotton. Now, the more advanced stethoscope is composed of earpieces made of steel coated in softened silicone rubber. The stem is made of metals including aluminum, chrome-plated brass, or stainless steel, and has tubing that is either polyvinyl chloride or latex rubber. As of now, the future for the stethoscope is looking to become more electrical, allowing a visual aspect as well. This stethoscope is changing to becoming more like a handheld ultrasound device. The flexible tubing of a stethoscope can either be made of latex rubber or polyvinyl chloride, or in a short, PVC, but the majority of the tubing uses the latter. PVC is a flexible and strong but lightweight plastic material that is durable even under changing temperatures and conditions. Due to its wide range of properties, PVC is the world's third most widely produced synthetic plastic polymer and one of the oldest synthetic materials to have been discovered, being used in everyday objects such as credit cards, water pipes, shower curtains, electrical wiring, and cables. PVC was originally discovered in 1872 when it was accidentally synthesized by German chemist Eugen Baumann. The polymer materialized as a white solid inside a flask of vinyl chloride gas that has been left exposed to sunlight. Not knowing its potential, the chemist did not follow up on his breakthrough. It was during 1913 when another German named Friedrich Heinrich August Klett made a patent for the polymerization of vinyl chloride under sunlight. By itself, PVC was intractable and thermally unstable. But an American scientist named Waldo Sermon discovered in the 1920s that the properties of PVC could be modified with the addition of plasticizer. Thus began its modern usage. Sermon used PVC to replace natural rubber as an insulating material for the wiring in military ships. Subsequently, other companies continued to develop and advance the usability of PVC in the 1950s onward. They refined the methods to enhance the synthesized material in order for it to be applied commercially. Today, the manufacturing process of PVC is manufactured in a process shown in this diagram. The vinyl chloride monomer is pressurized and liquefied and then fed into the polymerization reactor, which contains water and suspending agents in advance. The initiator is then fed into the reactor, and PVC is produced under a few bars at 40 to 60 degrees Celsius. PVC is versatile. It can be a rigid industrial pipes used for building and construction applications, as pliable as plastic shrink wrap used for packaging, and as thin and flexible as wall covering or medical tubing, such as the stethoscope. Because of its cheap price and easy processing, about 40 million tons of polyvinyl chloride are being produced per year globally. In fact, about 20% of the medical plastics and over 50% of medical goods are made from PVC. It is important not just in, but also in construction, electronics, other everyday products, and many other applications.